Welcome to True Projects. In this video, we are going to discuss about the project which is eye tracking based diagnosis and early detection of autism spectrum disorder using machine learning and deep learning techniques. So let's understand what is the project about. So you all know that what is this ASD, that is autism spectrum disorder, right? It is this condition where people have different challenges with how they act, how they interact with the others and how they connect with the others. So it is generally a complex neurodevelopmental condition. And it is actually pretty common that affecting about 1 in 160 kids globally, which is quite a lot when you think about it. So generally one kid in 160 kids are affected by this ASD. So now the thing is, even though autism usually starts showing up when kids are really young, like toddlers, it often goes unnoticed or undiagnosed until they are around 4 years of their age. So until they are of 4 years age, doctors or anybody will not get to know that they are affected by this ASD. So that's because it can be tricky to spot and it takes time for doctors to be sure. But here the thing is, spotting autism earlier is super important. Why? Because the earlier someone gets help and support, the better their chances are of overcoming some of the challenges that come with it. And trust me, those challenges can be tough, things like trouble communicating, understanding emotions, or making friends. So imagine if you could find a way to detect autism sooner, like with some cool technology or something. So here the thing called eye tracking is used. Eye tracking, it's like a special camera that watches where your eyes go. So it can help to spot signs of autism spectrum disorder early on. People with ASD often look at things differently and eye tracking can pick up on that. And the best part is it is not too costly and it works well for all kinds of ages. So what are we going to do in this project is we are going to develop an efficient system that will accurately detect this autism spectrum disorder using machine learning and deep learning by using eyeball tracking images. So in this project, we are going to develop an efficient system that will be built using machine learning and deep learning models on the eyeball data, that is eyeball tracking data. So in this project, there are three methods introduced to help diagnose with ASD early. So first, we have developed feed forward neural network and artificial neural networks. So these networks, they work together to classify features extracted from a mix of local binary pattern, that is LBP, and gray level co-occurrence matrix algorithms. And then we have implemented the other method. So that focuses on using convolutional neural network, pre-trained convolutional neural network models like GoogleNet and ResNet. So these models, they excel at capturing, extracting deep features from the data. Lastly, we have used hybrid models that are combined with GoogleNet and SVM and ResNet with SVM. So these models combine deep learning with traditional machine learning for even better diagnosis. So basically, we are combining different AI techniques to improve how we spot this ASD early on. Once we train the models and assess their performance using accuracy, precision, recall, and FN score, we select the best performing model. So the best performing model is feed forward neural networks. It is chosen and saved for deployment. And we deployed our project using Flash framework, which is integrated with web application, that is SQLite web application. So moving on to the front end integration, we have chosen Flask as the front end, that is web application. So Flask is like a lightweight web framework for creating websites using Python. So we used this in project to make a website where people can interact with our autism spectrum disorder detection system. With Flask, we can set up features like sign up and sign in using a simple database called SQLite 3. So users can upload images on the website for analysis. Flask helps manage to all these interactions by directing them to the right parts of our project, where the images are pre-processed and predictions are made. In this way, users can easily use project through a web browser. So to implement this project, we need some requirements and they are software and hardware. So coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So coming to the hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So moving on to the algorithms used, these are the algorithms which are built in the project. So after training and evaluating all these models, we found that this feed forward neural network has performed well. So let's understand this. What is feed forward neural network? Feed forward neural network plays a crucial role in classifying features extracted from eye tracking data for the early detection of autism spectrum disorder. So the feed forward neural network, it is a type of artificial neural network characterized by its structure where information flows only in one direction from input to output without any feedback loops or cycles. So it consists of interconnected nodes organized into layers, including an input layer, one or more hidden layers for processing, and output layer for making predictions. So this FFNN model is employed in this project, which comprises an input layer, hidden layer, and the output layer. Each layer is fully connected to the subsequent layer with neurons. In each layer connected to all neurons in the next layer. So this interconnected structure allows the network to process and learn complex patterns from the input data. So this FFNN classifies features derived from a combination of local binary pattern, that is LBP, and gray level co-occurrence matrix, that is GLCM algorithms. So it takes in the data from LBP and GLCM algorithms, which analyzes patterns in images and then processes the data through layers of interconnected nodes to make predictions about whether a person has autism spectrum disorder or not. So we understood what is this FFNN. Now let's execute the project. To execute it, we need to open the code folder which contains source code files. So these are the source code files in the code folder of our project. So let's understand each file, how will they be used in our project. So first, let's explore the dataset folder in which we have dataset. So open it. Here we have two subfolders. One is TCI images and the other one is TSI images. So in TCI images folder, we have images related to no autism spectrum disorder, that is no ASD. Moving on to TSI images, we have images related to autism spectrum disorder. So the people who have autism spectrum disorder, so these images are of that people. So let's open this TCI images folder and see what are the images in it. So these are the images in the TCI folder. So we can see that all images are in black, right? So I'll show you a sample. I'm opening it. Here, if we zoom in the image, we can observe a spider web like thing, right? So this is the eyeball movement captured. So this movement is captured from other technical devices. So here we can observe a eyeball movement image. So close this. Similarly, we have in other images also. If we zoom in, we can observe. So here we can observe. Now close this. So these are all the images. They are of eyeball tracked images. So we'll be using all of these images to train the models. So similarly, we have here autism spectrum disorder images. So if I open it, here you can observe eyeball movement, right? So this is an eyeball movement. So now close this. Similarly, we have in other images also. So here we can observe that eyeball movement. Now close this. Similarly, we have in all other images also. So after tracking all these images, that is eyeball tracking, we will train all the models. So we'll be using both of the folders to train the models. After training, we will test the models. Now get back. So this is the model file in which we have the algorithm information, and this will be loaded into the project code during runtime. And here in the sample folder, we have the test cases. So we will be using all these images as the test cases in the front end to detect whether a person has autism spectrum disorder or not. So now get back. Moving on to the next folder, which is static folder. This folder contains files related to CSS, JavaScript, and Bootstrap files. So these files, they are important for project styling and the interactivity. And this is the templates folder. Here lies all the HTML pages that are utilized in the project, such as index.html, about.html, etc. Each HTML file represents a different page of the website and provides structure and layout for displaying content to the users. And here we have app.py file. So this Python file encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be represented in HTML templates. So here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And the last file which we have is signup.db file. This file is a database file which is used to store the user information. So now we have to copy the path of the code folder from the address bar of the file explorer. So copy the path. Now open the Anaconda prompt. So here using the command cd followed by the space, we need to paste the copied path and then click on enter. Here we can observe that current directory is changed to the code folder's path. Now we have to compile app.py file. So give the command python space app.py and then click on enter. This app.py file, it will execute Python script and it will perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash framework will host the application locally at the default address, which is localhost and the port, unless configured differently. So this is the localhost and this 5000 is the port. Now copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. So paste the link here and hit enter. So this is the web page of the project, which is displayed in the browser, and this web page is built using Flash framework. So first we have to sign up. So click on sign up and enter all the registration details if we are registering newly. I have already registered and I have an account in it, so I will directly sign in. So click on sign in and enter username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page. So here we can see a choose file button, right? So click on that for uploading the eyeball movement images. So click on choose file. So these are the test cases using which we'll be detecting ASD in the front end. So select the image. I'm selecting the first test case. That is the first image. Click on open and now upload it. So after uploading the image, here we got the prediction as ASD diagnosed. So from the image, application has detected that autism spectrum disorder is detected and that has to be diagnosed. So let's upload some more images. Click on try again. Now click on choose file to upload some more images. I'm going to upload the third test case. Click on open. Image is loaded. Now upload it. So here we got the prediction as no ASD diagnosed. So from the uploaded eyeball movement image, here we got the prediction as no ASD diagnosed. That means that no autism spectrum detected. Let's try using some more images. Click on choose file. So we will upload the first fourth test case. Click on open and now upload it. So here we got the prediction as no ASD diagnosed, which means that no autism spectrum disorder detected. The person is perfectly all right. So let's upload some more. Click on try again. Click on choose file. So now let's upload six test case. Click on open and now upload it. So for the uploaded image, here we got the prediction as no ASD diagnosed. Let's upload some more. Now we'll try using the seventh test case. So for the uploaded image here also we got the same prediction, that is no ASD diagnosed. We'll try using some more. Click on choose file. Upload the eighth test case. So here also we got as no ASD diagnosed. Let's upload some more. Click on choose file. Upload the ninth image. So here also we got the same prediction, that is no ASD diagnosed. Let's upload some more. Click on try again. I'm uploading the 11th image, that is 11th test case. So here we got the prediction as ASD diagnosed. That means that application has detected autism spectrum disorder from the uploaded eyeball tracked image. So let's upload some more images. So click on try again. Now we'll be uploading the 12th test case. So here we got the prediction as ASD diagnosed. So let's try using some more images. Click on try again. Click on choose file. So we'll be uploading the 13th image. Click on open and now upload it. So here also we got as ASD diagnosed. That means that the application has detected autism spectrum disorder from the uploaded eyeball movement image. In this way, just by uploading images to the system, it will detect, that is autism spectrum disorder will be detected if person has, or if the person doesn't have the autism spectrum disorder from the eyeball image, then it will detect the same. So now click on sign out. So the project demonstrated the effectiveness of using advanced AI technologies, that is machine learning and deep learning, particularly feed forward neural network, to improve early detection of autism spectrum disorder using eye tracking data. So by combining machine learning and deep learning methods, the project successfully identified ASD cases, enhanced data quality, and extracted relevant features for accurate diagnosis. This approach has the potential to enable quicker and more accurate ASD diagnosis, facilitating timely intervention and support for affected individuals.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.